Today we're going to be graphing from vertex form. So vertex form is different than standard form. It is where you have the vertex clearly stated in the equation itself. So your vertex is going to be at the point h comma k when your quadratic is written in this way. So you're going to have f of x equals your a value is going to be out in front. Your b value is going to be inside your parentheses, factored out from your x minus h, and then you have the plus k at the end. Notice here how it is a minus h in your formula. So whatever sign is here, you're going to do the opposite of that when you find your vertex. Once you know your vertex, you're going to graph wherever h comma k is, and then you're going to do your 1, 3, and 5 pattern from there to get that nice quadratic or U shape. So A, B, H, and K all do different things to your graph. They're going to move your graph around or stretch it. So for these ones, your H value, I'm going to start with that. Your H value is going to move your graph left or right. And it's going to move left if it's something like x plus a number squared. It's going to move right if it's x minus a number squared. Once you identify your H value, you're going to move to your B value. Your B value also works upon the X. So B and H change your X values, which means for your B value, that is going to be a horizontal, stretch, or compression. So it is getting stretched or compressed left to right. Now, since it's inside, anything that's inside does the inverse of what you think it should do. So if it's inside and it's your B value, it's going to be a stretch if your B value is going to be a fraction between 0 and 1. It is also then going to be a compression if your B value is greater than 1. So if your B is 3, it's actually getting compressed left to right by 3. Likewise, since it's horizontal, it's also going to be a reflection over your y-axis. So reflect over your y-axis. Okay, because that's going to be switching it left to right or reflecting it left to right. So B and H act upon your x values. A and K act upon your y values, your output. So what's happening with your A value? That is going to be your vertical stretch or compression. And it's also going to be your reflection over your x-axis. So the vertical stretch is going to be if A is greater than 1. The compression if A is between 0 and 1. Woof, there we go. And then it is going to be a reflection over the x-axis if A is negative. For your K values, that's going to move your graph up and down. And so that's going to do exactly what you think it is. So if it's plus a number at the end, it moves it up. If it's minus a number, it moves it down. So let's take a look at example 1 here. So we want to graph this and then basically do everything else from there. So this 2 out in front is your A value. That means there's a vertical stretch of 2. The plus 1 is your H value. Since it's plus 1, it's actually going to be moving my graph left 1. And the minus 8 at the end here, this is my K value. So when I write my transformations, I'm going to do H and B first. So I'm going to move my graph left 1. There is no B value. So after I do my H and B, then I'm going to talk about my A and K. So the A being 2 is a vertical stretch of 2. And then minus 8 is going to move my graph down 8. So based off of that, if you can imagine your vertex, normally your vertex is at 0, 0, but you want to move your graph left 1 and down 8, that's going to be your new vertex. So therefore, negative 1 comma negative 8 is our vertex, and that matches with the H comma K from earlier. Since A is positive, this is once again going to open up Since my A value is 2, I'm going to do the 1, 3, 5 pattern, but I'm going to multiply it by 2. So over 1 up 2, over 1 up 6, and then over 1 up 10. And you're going to make it into that nice parabola or U shape. And once again, mine looks pretty bad. I'm sorry about that. Just bear with me. Pretend I actually hit my marks there and went through the points. Okay, so it should be this nice U shape. Okay. Based off of this, my axis of symmetry is x equals -1. My y-intercept here is 0, -6. You have to be careful. Sometimes you have to go hunting for your y-intercept. So imagine plugging in 0 for x into your original equation. We don't have a clear y-intercept like we do in standard form. You're going to have to go solving for it. So you're going to do your order of operations in order to get to that -6, or in order to hunt for it if it's not on your graph. Your x-intercepts are -3, 0, and 1, 0. Domain is always negative to positive infinity for quadratics. My range is always going to deal with my k value. So it's either that to positive infinity if it opens up, or negative infinity to that if it opens down. So increasing is going to be the right half of my graph here. So for increasing, I'm going to start when x is -1 and go to the right. Decreasing is my left half of the graph here. So it's going to start at negative infinity and end when x is -1. Let's try another one. We're now going to work backwards. So we have this graph. We want to write this in our vertex form. So looking at this, our vertex here is at 5, 0. So therefore, when we are plugging this into our vertex form, since it's moved right 5, it's going to be x minus 5. Since our k value is 0, we're going to have just nothing at the end because that's the same as plus 0. And you're going to have to look for your a value. Normally you go over 1, up 1, then 3 and 5. And this actually is following that pattern, which means a is 1. So this is actually our equation in vertex form. Now we can go through and answer the rest of those. Your axis of symmetry is going to be x equals 5. Notice here you're asked for the roots, which are your solutions. So instead of writing 5, 0, you're going to write it like an answer, x equals 5. My y-intercept is not on the graph. Now that does not mean that it doesn't exist. You will still get a y-intercept. So what we're going to do is we're going to plug in 0 for x, because it's always going to be 0, something, and solve. So when we do 0 minus 5 and then square that, we should get 25 for my y-intercept. Domain negative to positive infinity. Range starts at 0 and goes up for forever. Increasing starts at 5 to the right. Decreasing starts on the left and ends at 5. Okay, so the back page is applications of this. I'm going to do one more together, and then I'm going to ask you to try the rest on your own by pausing the video. So let's do B together first, and then I'm going to ask you to pause the video and try the rest. So for B, we're going to identify our vertex here and graph it. So it's going to be at the point -4, -2, and we're going to plot that point. Then we're going to do the 1, 3, 5 pattern, but we're going to multiply that by 3. So I go over 1 up 3, and then over 1 up 9, and then I'm going to stop. And before I graph this, I want you to look carefully at this. Look at B. We have an inequality here. So if it's an equals, you just draw your graph like normal. So A is just going to be your normal graph, but B and C are inequalities, which means you have to think about dotted versus solid. And so for this one here, since it's not equals, it's going to be a dotted or dashed line. So we're going to connect this parabola through those points with that dashed line. You also have to deal with shading then if it's an inequality. So greater than or less than, you want to do shading. So once again, we're going to pick a test point. So I'm going to test the point 0, 0. So I'm plugging 0 in for y and 0 in for x. And so when I actually figure all of this out, I get 0 is less than 46, and I get a true statement. So if I look at 0, 0, 0, 0 works. So it has to be in the shaded region. So I'm going to be shading everything on the outside of this parabola. If 0, 0 did not work, I would shade everything inside the parabola. So what I want you to do now is pause the video and try all of example 3 and then read through example 4 and try something with that. And then once you've tried it, you can come back to the video for those explanations. Okay, so you can take a look at 3. You have your vertex at 6, 3. It opens down with a stretch of 2. Versus C, it has a vertex of 0, -5. It's a solid line, and you shade on the inside of that parabola. So looking at example 4, when we have our vertex, we know h and k, so we can immediately plug in h and k into our equation. So to find a, what we can do is we can use the other point given to us as our x and our y coordinate. So what I can do is I can say y is 3 and x is 4. And that means the only thing missing then is my stretch, because if I know h, k, and a, I have enough information to go off of. So what I can do is 4 minus 2 is 2. 2 squared is 4. And so then solving for a, I add 1 and I divide by 4. I get a equals 1. So therefore my equation should be y equals 1, which I'm not going to put there, and then x minus 2 quantity squared minus 1. The next one is going to be the exact same idea. So if you needed a little bit of an explanation for number 4, try pausing the video one more time and trying to solve for a that way, and then come back and check. So my y value here is -3. My x value here is 4. My vertex was -4, 6, so I plugged that in. So when I add those together and then square it, I get 64. And therefore, a is going to be -9 over 64. So this one is not as nice as the other one. You get -9 64ths, parentheses x plus 4, quantity squared, and then plus 6 at the end. So thank you very much for listening. Hopefully this helps. And if not, let me know if you have any questions. Thanks.